Hi and Assalamualaikum. So previously in chapter 4 application of differentiation, we have learned about equation of tangent and normal, how to find relative maximum and minimum using the first derivative, and so do the inflection, how to find the inflection point. So for this week we're going to learn about this, which is method 2 using second derivative test. So let's see the first example. Now you need to find the relative maximum and the inflection points of given this function fx equal to x cubed minus 3x squared, and then you need to sketch the graph. So first we know that we have to start with the first derivative. So you have to differentiate this function, then you will get this 3x squared minus 6x. Then this equation is actually equal to 0. In order for us to find the critical values. So after this equal to 0, then you get x equal to 0 and x equal to 2. So this will be your critical values. Then by using the second derivative test, we will have f double prime x equal to 6x minus 6. So this is after we differentiate after second derivative. So now we have to substitute our value of x, since we already knew that our x value equal to 0 and x value equal to 2. First, we need to substitute x equal to 0 into the second derivative. So you get negative 6, which is negative 6 less than 0. So this will be a maximum point or relative maximum. But now you only have x value. So you will need y value in order for you to determine the point. So we have x equal to 0. Now you have to substitute x equal to 0 into f, the f function, not this one, to the f function. Then you will get your y equal to 0. So this is complete. You have x and y, so it become a point. So you have a point over here which is 0, 0. This is known as a relative maximum. How do you know it is a relative maximum? From this, you have it less than 0. So this indicate that it is a relative maximum. Next, finish with x equal to 0. Next, you have to substitute x equal to 2 into this function. So now when we substitute x equal to 2 into the second derivative, you will get the answer equal to 6, where 6 is greater than 0, which means that this is gonna be your relative minimum. But now you only have x value equal to 2, so you have to find the y value. So you have to substitute the x into the f function, the original f function. Then you will get y equal to negative 4. So now you have a point, x equal to 2, y equal to negative 4. So this point going to be your relative minimum. So remember two things. When you have when you already substitute the value into the second derivative function, when you have the less than 0 value, that indicate that you're going to have a relative maximum. When it is greater than 0, that indicate a relative minimum. After we find our relative maximum and relative minimum, now we're going to find the inflection point. So how do we find inflection point? Remember, using the second derivative, equal it to 0. So the second derivative is 6x minus 6 equal to 0. So you will get x equal to 1. Only one value. So when x equal to 1, therefore your y will be equal to negative 2. Okay, how do I get this value y equal to negative 2? Is from substitution. You substitute x equal to 1 into the f function. again into the f function, not this. Okay, then you will have the inflection point is 1, negative 2. So next you're going to determine the concavity. So we know that our interval start from 0 and end with 2. How do I know that? Through this, the first x values you found, or the critical values. So this is going to be the interval. Start from 0 and end with 2. But in the middle, you will have 1 over here, since we have this from the inflection point. So you will have start with 0 until 1, then close bracket, and then we start again with new interval 1 until 2. Okay, now you already have 2 intervals. You're gonna have to substitute any value within this interval. Let's say I pick 0.5 for this value because 0.5 is in between or within this range. Okay, and here I pick 1.5 because 1.5 within this range. So now when you have this value, any random value here, you're going to substitute this value into the f double prime, this one, since we're going to find the sign of f double prime x. So when we substitute this 0.5 into this function 6x minus 6, you will get negative value. And the other one, when you substitute 1.5 into the f double prime function, you will get positive value, which then we can conclude that from here we have negative, means that the concavity of the curve is downward. For this interval, it's going to be concave downward. So concave downward look like this. And for this one, since it is positive, you're going to have concave upwards. So it's going to be like this. So can you imagine your graph now? We have quite a little bit of hints over here. This one and this one. Okay. So 1, negative 2 is an inflection point. To find intersection point is when x equal to 0, y equal to 0. Intersection point means the pintasan of paksi y. Okay, now you have inflection point and you already found the concavity. How does it look like? Now we're going to draw or sketch your curve, sketch the graph. Okay, so this is how the graph will look like. If you refer back to the one with in the table, it's quite similar, right? Here, it's going upward and then it's going like that. So this is the one. So 0, 0 will be the pintasan paksi y, or the intersection point over here. When you substitute x equal to 0, you will also get your y equal to 0. And the inflection point is somewhere around here. Since it is 1, negative 2, so the inflection point is over here. Inflection point means where the curve starts to change. And then here is the relative minimum. This is the relative minimum point and this is the relative maximum point. Let's see the next example. Find the relative extremum and the inflection points of this function. Relative extremum means you need to find whether both relative maximum and relative minimum. Okay, first thing you need to do is to differentiate this function. So after you differentiate this, you will get this. So we know that in order to find the critical values, you have to equal this to 0. The first derivative must be equal to 0. So we have this equal to 0, then you get x equal to 0, x equal to -1 and 1. This one you can solve it using calculators, using the equation function, the quadratic. Okay, then so we already found our critical values. Next, by using second derivative test, so we have our first original function, then we differentiate the first, we differentiate it first to get our critical values, then we differentiate it again so we have it this one. So now when x equal to 0, you substitute x equal to 0 into this second function. Because we have these three values, so you're going to substitute each of it into this. So the first one, let's substitute x equal to 0 into this, then you will get f double prime x equal to 0. So we can say that no conclusion can be met. So for this, because we have x equal to 0, f double prime also equal to 0. Now let's test for the x equal to -1 and x equal to 1. So when x equal to -1, we substitute this value into the f double prime. You will get -30. When -30 is less than 0. So this indicates that you're going to have a maximum, relative maximum. So then we already have x value equal to -1. Of course, you're going to find what is your y value, right? So -1, you substitute into the f function. Substitute into the f function, you will get 2. So it's a point now. You have -1, 2. This point is your relative maximum. Okay. Then we're going to test for x equal to 1. So again, x equal to 1, you substitute into the second derivative, then you get 30, where 30 is greater than 0, which indicate that you're going to have relative minimum. So now you only have x values, you're going to find the y value. So substitute x equal to 1 into your f function, so you get -2. So this point, 1, -2, indicate your relative minimum. So now you have found your relative maximum and relative minimum. Next step is to find the inflection point. So how to find the inflection point? We find this we find the second derivative and then equal it to 0. So you have these values, x equal to 0 and x equal to half. So you're going to have two inflection points since you have two x values. So since we have these values, x equal to 0, x equal to half, let's check for the concavity first. So we have this interval start from -1. Why do we start with -1 not instead of -infinity? Because if you refer back from this, the stationary value, from the critical values you have found earlier, we have three values of x, which is 0, -1, and 1. So pick the smallest value, which is -1. So we will start with -1. -1 until 0, and then close bracket, and then we start with a new one, 0 until half. Where does this half come from? Here, from the inflection point you found just now. So we're going to add half in here, and then close bracket, and then we start a new interval, start with half until 1. Enough until 1, because if we refer back, this 1 is the largest values. So stop until 1. So now you have three intervals. Now you're going to find the value of x. Pick any value within this interval, and within this interval I pick, let's say I pick negative 0.5 because it's in this interval, and negative 0.25 also in this interval, and 0.75 also in this interval. So we already have our value of x, so you're going to substitute these values of x into the f double prime function, the second derivative. So you get, for this interval you're going to have positive answer, and for this interval you have negative, and this interval you have positive, which indicate that for positive indicate that it concave upward like this, and negative indicate concave downward, and again positive you have concave upward. So from here you can imagine how your graph look like actually from this curve. Okay, since we already have our inflection point, the x, only the x values, remember you need to find the y values for this. So when x equal to 0, we substitute into the f function, you get 0. And then the second one, when x equal to half, you substitute again into the f function, you get 17 over 32. So you have 2 points now, this one and this one. We can sketch our graph. So these are the inflection points we found just now. So of course you need to find the intersection point, where does this curve pintas the y-axis. Okay, so when x equal to 0, y equal to 0 over here. The graph or the curve pintas paksi y in here. So for the curve sketching, let's refer to the previous table we found. Okay, let's see from negative 1 until 0, this area, right? This area. So you're going to have a little bit of concave downward, and then over here from 0 until half, here 0 until half, you're going to have a little bit of downward, you see over here, downward, a slight downward, and then we have concave upward starting from half, over here half until 1, it's concave upward. So this is how your graph look like. And don't forget to label your graph, where your relative maximum, where your relative minimum, where your intersection point, where your inflection point over here. Okay, you might want to try the exercise on your own, so please try it, otherwise you won't know whether you can do it or not. Next is to find the relative extremum using the second derivative test. Second derivative test can determine the maximum and minimum values of a function. So this is basically what we have learned previously, or what we have used before. Let's see. If f prime c, or the first derivative of c equal to 0, then the second derivative of c greater than 0, then f has local minimum at c. So remember, if greater than 0, that will be minimum. If you have less than 0 over here, the second derivative less than 0, then you will have local maximum. If f prime c equal to 0 and f double prime c also equal to 0, then the test failed, it is inconclusive. So this is quite interesting, and it's easier to remember if you have the first derivative equal to 0, also when the second derivative also equal to 0, then we consider this test fail. It is inconclusive. Thus, the first derivative test is used only when this thing happen. Okay, let's see example. By using the second derivative test, find the relative extremum of this function. So first, you need to find the critical values. How do you find critical values? We do the first derivative. So from f here, you differentiate, you get this. Then from here, you can straight away using calculator to find the x value. Um, uh, of course, for the f prime x, you're going to equal it to 0. Then only you can find your x. So you have two x values, x equal to -2 and 4. So these are the critical numbers or the critical values. To determine the relative extremum, the second derivative is used. Okay, then here is the first derivative. So you're going to differentiate it again, then you get this part. So after you have this part, you're going to substitute the x values you have just now. We have two x values, which is -2 and -4. The first one, when x equal to -2, your f double prime x equal to -8. You substitute the x value into this, you get -18, which is less than 0. And the other one, x equal to -4, we substitute into this, you get 18, which is greater than 0. One is less than 0, one is greater than 0. Then you only have x values. Of course, you're going to find the y values, right? So again, you substitute the x value into the f function. Then you get 60. So now you have a complete point. Also with this, you substitute the value into the function, you get this one. So you have 2 points now. But remember, right, you have here less than 0, greater than 0. So if we recall back to the statement given previously, you will have local minimum when your second derivative of c greater than 0. And you will have local maximum when you have second derivative less than 0. So we can conclude that by the second derivative test, point -260 is a relative maximum. Why is it relative maximum? -2 and 60. Because it is less than 0. And the second one, for point x -4 and -48, you have over here greater than 0, which means you will have local minimum, or we can say it as a relative minimum. Example 2, by using the second derivative test, find the relative extremum of this function. So like usual, you're going to find the first derivative, which is this, and then you're going to equal the first derivative into 0, equal it with 0, then you have your x values, which are also known as your critical values. So we have x equal to 0 and x equal to 3, and then you're going to find the second derivative. So from the second derivative, you will have x equal to 0. And when x equal to 0, f double prime x equal to 0. You just check it back. When you have this x value, you substitute this value into this, the second derivative. And remember, when you get this also equal to 0, the test fail. It is inconclusive. Thus, the first derivative is used because both the first derivative and the second derivative equal to 0. So the test fail. So the first derivative is used. Let's see over here. When the first derivative equal to 0, we have two values, which are x equal to 0 and x equal to 3. These are your critical values. So we're going to have our intervals start from -infinity until 0, and then start with the new one, 0 until 3. Okay, then you're going to find any value of x and let's say -1 and here 1, substitute into the f prime, not f prime, not the f double prime. This time we're going to use the first derivative because the second derivative mentioned, the second derivative previously, we consider it as fell. We consider the test as fell. So you're going to use first derivative. So now you have negative, and you substitute -1 into the f prime function, you have decrease, and also this one also decrease. Hence, the first derivative test shows f does not have a relative extremum at x equal to 0. Okay, that one is for x equal to 0. How about x equal to 3? At x equal to 3, your f double prime x, you get 36, which is greater than 0. So you know that when you have greater than 0, it's going to be local minimum. From here, when you have f double prime greater than 0, you have local minimum. So you're going to have, now you have x, you're going to find the y value. So you substitute this x value into the f function. F function, remember, not the f double prime. Always substitute into the f function. So you get the y value. So this is the point. So this point 3, -27 is a relative minimum. We only have one relative minimum. We don't have the relative maximum because the x equal to 0, we don't have a relative extremum. No relative minimum, not also the relative maximum. So finish with relative maximum, relative minimum, inflection point. And now we're going to solve optimization problems. It's quite related with the one you have learned. It's just that this time around you will have a problem to solve. So basically there will be five steps for solving optimum problem. So the first step is to identify the variable for to be maximized or minimized. Say variable y. You need to identify the variable first. The second step is to express y into a single variable function. Say y equal to fx. Then the third step, you're going to solve for f prime x equal to 0. Remember this part? This is how you're going to find your x values, right? Your critical x value when the first derivative equal to 0. And then the fourth step, verify the solution of f prime x equal to 0 by the second derivative. Okay. And last step, get the optimum value y equal to fx if it is required. So this is example 1. You have been asked to design a 1-liter oil can shape like a right circular cylinder. So you have this can and you need to design a 1-liter oil. A 1-liter oil can shape like this. This is a circular cylinder. So what dimension will use the least material? Yang menggunakan paling kurang material. Dimensi apa yang menggunakan paling kurang material? So, we know that circular cylinder is like this. You will have the 2R or the radius, and then over here you have the height, tinggi dia. So, for the solution, volume of can. For this problem, you will need to remember or recall whatever you have learned in your during your SPM. So you need to know what is the formula for volume for the cylinder, of course. Otherwise, you can't start. So volume of can or indicate by capital V equal to pi r square h. Pi r square h. And it equal to 1000. How do I know it's 1000? Because 1 liter. 1 liter equal to 1000 ml. So it's equal to 1000. So now H equal to we refresh ataupun kita susun balik the H. So you only have H over here, the rest you're going to bring it on the other side. So you have this single H. H equal to 1000 divided by pi r square. Because this pi r square, you bring it over here. So you know that the height will be this value. Then we also know that surface area of can, surface area ataupun permukaan tin itu adalah, also this formula is what you have learned previously during your SPM. So you need to recall or you need to Google it. Okay, so this is the formula for area for cylinder, and this is volume for cylinder. So you will have 2 pi r square plus 2000 over r. Why is it 2000? Because you have two surface over here. You have dua permukaan bulat. Dekat atas ni satu, dekat bawah lagi satu. Permukaan tin dekat atas satu, dekat bawah lagi satu. So you have 2000 over r. Then you will have dA over dr. Why is it dA over dr? Because you have A over here and R over here. So we will differentiate the A with respect to R you have over here. So that's why you have dA over dr. So you have then you can differentiate. So slowly we differentiate this. When we differentiate 2 pi r square, 2 up here you're going to multiply with 2 over here, so you get 4 pi r. So pi is a constant, just leave it here, pi. And r square just now minus 1, so you get r minus 2000 over r square. This one because you already differentiated it, so you get this. Okay, then you will have your critical point or your critical values. So this is actually the third step. dA over dr, what you have found in here, you're going to equal it with 0. So it's going to be like this, dA over dr equal to 0. This is the one we have found. So again, you're going to rearrange or reconstruct your equation. So kita kembang-kembangkan and susun semula, then you get make your r on this side. Jadikan your r sebagai penyebut lah dekat sini. So you will have r cube equal to 5000 over pi. This one after you rearrange, you bawa pindah-pindahkan dia, then you get r cube 5 equal to 500 over pi. So the r will be punca kuasa 3 this thing, which is you can calculate it using calculator, then you get it approximately 5.42. The r here is your radius, okay, radius or jejari. So you get your r or radius equal to 5.42. Radius is only start from here until here, half of it, radius. And your height will be 1000 over this. Okay, this is from the previous one we have found earlier. So you just substitute the value of r inside. So you get 10.84. So this is the height, the tinggi. You already found the tinggi and the radius, the jejari. So that is the values that going to help you build the can with the least material. Now let's move on to example 2. An open top box is to be met by cutting small congruent squares from the corners of a 12 cm by 12 cm sheet of tin and bending up the sides. How large should the squares cut from the corners be to make the volume of box maximum? So basically what you have here is you're going to build an open top box, satu kotak yang mana permukaan atas dia terbuka, open top box, and then you by cutting small congruent square. Congruent square mean segi empat sama, yang mana dia punya corner adalah 12 cm times 12 cm. Ni adalah 12 cm lah. So you're going to cut it into small piece of 12 cm. Okay. So dekat sini soalan mahu how large should the square cut from the corners? Berapa besar the square dekat tepi ni, dekat bucu ni yang patut dipotong to make the volume of box maximum. Sebab lagi besar kita potong ni, bila kita tegakkan kotak ni macam kita buat apa? Kotak DIY. So bila kita lagi besar kita potong dekat tepi ni means lagi dalam kita punya kotak. So solution, we have V volume equal to X times 12 minus 2X times 12 minus 2X. Okay. Volume adalah untuk ni, for this box, you have X over here. Bila kita tegakkan dia kan, bila kita lipat untuk jadikan box, you have X. Seolah-olah X ni adalah dia punya tinggi lah kalau kita lipat kan. X, and then permukaan sisi dia adalah 12 minus 2X. Kenapa ni kan asalnya 12. Kenapa 12 minus 2X? Sebab originally this is 12. Di sini ada X. Di sini pun ada X. So ada 2X. That's why kita minus 12 minus 2X. Sini ada X, sini ada X. So minus 2X. Okay, itu baru bucu sebelah sini. How about bucu sebelah sini pula? Bukan bucu, sorry. Side. Yang permukaan sebelah sini pula. So, the other sides you will have the same. 12 minus 2X. Originally, this is 12. Over here, X. Over here, X. So, you have 12 minus 2X. So, that's why you have this. Okay, then you need to expand this. Kembangkan dia. So, you will get this. Now, you have V, you get X. So, can you differentiate it? Yes. We will differentiate dV over dx. Differentiate V with respect to X over here. So, you get this part. Again, using the first derivative, equal it with 0. So, this whole thing going to be equal to 0. Again, you're going to find your X values. So, you have two X values, X equal to 2 and X equal to 6 over here. So, next, from this, you already found the first derivative. You're going to find the second derivative. The second derivative, again, you differentiate this, you get this. So, you have two values of X previously, X equal to 6 and X equal to 2. When X equal to 6, you substitute this value into this. So, you will get greater than 0. The value will be greater than 0. And which is greater than 0 mean you will have V is minimum. When again you have X equal to 2, substitute into this value, you will get less than 0, which indicate that V is maximum. So The area of each squares to be cut from the corners is 2 times 2 equal to 4 cm. How do I know 2 times 2 equal to 4 cm? Because this. Instead of using 6, instead of using x equal to 6, I choose x equal to 2 because this one will bring you to maximum v. You will get from this value of x equal to 2, you will get the maximum volume. See? And this one, we didn't choose this one x equal to 6 because your v going to have your volume going to be minimum. So choose this one, maximum. So that's why the area of each square to be cut from the box or from the corner is 2 times 2, the x value. X value itu adalah 2 equal to 4 cm. That's it. Okay, you might want to try this exercise also. Quite similar with the one with the second example. Okay, you see, you have 8 centimeter, and then over here you get x, so it's going to be 8 minus 2x, and how about this? This is going to be 3 minus 2x, so it's quite similar. Please try it.